This is the Smart Buildings Academy podcast with Phil Zito, episode 365. Hey folks, Phil Zito here, and welcome to episode 365 of the Smart Buildings Academy podcast. In this episode, we are going to be continuing along with talking about deploying IP controls and designing IP controls. So in the previous lesson, or previous episode 364, we went through IP controls frameworks, things like that. And now we're going to go over to the whiteboard in this episode, and we're going to start with some relatively simple diagrams. We're going to just talk about parts and pieces, and then we're going to get into some more complex diagrams, just talk through some general theory. I'll be popping between here and the whiteboard, so there may be a delay in me answering any questions. As always, everything will be available at podcast.smartbuildingsacademy.com/365. About an hour after this live stream, give or take. And like always, if you are trying to learn more about IT, definitely check out our IT course. And if you're finding this content valuable, please like, subscribe, and leave comments wherever you're listening to this. All right, so just a brief recap of last week, and then we're going to get into the whiteboard. Do be cognizant the sound is going to change when I move over to the whiteboard because we're moving from a podcast mic to a floor mic, so it may sound a little echoey, but it'll be all right. Last week, we talked about IP controls. We talked about what they are. We talked about there being three architectures. There's going to be a ring architecture, a star architecture, and a bus architecture. We talked about when you would use each one, and we talked about the pros and cons of each one. We talked about the basic process for going and initiating a IP design, and that is, step one, identify the scope, step two, locate the network, and step three, design the schema. In today's episode, we're going to start off with a really simple star architecture. We're going to move from there to a bus architecture. We're going to move from there to a ring architecture, and then we'll start looking at multi-building architectures, and we'll talk about concepts like routes, VLANs, etc. And like I said, I'll be hopping in and out of the desk here to look at your comments because I'm not going to be able to see your comments over on the whiteboard. All right, so the first thing I'm going to do here is I'm going to switch our audio. It's going to sound a little different for a second, but it should be good. All right, I'm going to sound a little distant now, but I'll sound closer as I get closer. Alrighty, let me see. Am I coming through? Yep. Okay, good. All right, so first off, let's make sure you all are seeing this on your end. All right, looks good. If you're listening to the episode, definitely go to podcast.smartbuildingsacademy.com/366, I believe, maybe 365. I don't have it in front of me anymore. And we'll be able to talk through that. All right, so they changed my layout on me a little bit, so this could be a little interesting. Let's see what we got here. I got pen here, and I want the color to be white. There we go. All right, cool. So the first concept we're going to talk about is the basic star pattern. This is what most of you are used to when you're setting up supervisory devices and some of your IP controllers at the plant level. So we start with a switch, right? And as we recall from last week's episode, this is typically a layer 2 switch, meaning that in order for you to get to any other part of the network, you have to use routers if you're stepping between subnets, but we're not going to be doing that just yet. We're assuming that we have a supervisory device on one physical port. For the sake of these diagrams, supervisory devices are going to be a box with an S, and controllers are going to be a box with a C. All right? And then servers will be a box with like a keyboard layout on it. So we've got a supervisory device, and this is a star run right here. So this right here, this white line from the switch to the supervisory device is a star run. Now, on the switch, we'll have another port, and this may go to a controller. This would be a central utility plant controller, a HU controller, maybe even a field controller. Now here, this is really, really simple. We have maybe this, and on this controller, if we're using some manufacturers' controller software or their supervisory devices, they may have a field bus, which for the sake of this, we're gonna make red. So our field bus would go to our controllers. This would be something like an MSTP bus, and we would have daisy chained controllers in red with, you know, our typical EOL at the end of the run. Let's make that an EOL. So this is a basic star pattern. It's what most of you right now are using across most of your jobs. Not very confusing, pretty straightforward. We get a design sent to us and it says, hey, I've got a 2-story office building. Maybe it's got a AHU and a dozen VAV boxes. So maybe this is what we do. We have a supervisory device, a controller, and we have on our trunk some field controllers. Now we can make this with newer systems and newer architectures. We can actually make some changes to things here. Let me grab the eraser real quick, and I'm going to kind of clear out this right here. Because what we can do with some of these newer architectures and newer controller lines are that some of the plant level IP controllers are actually coming with MSTP buses on the controller. So what I'm now able to do is have my controller, which will have my graphics, it'll have my trending at a low level, alarms, etc. And then from here, I will have my trunk. And so I'm able to reduce that supervisory device cost. So right here, I'm going and I'm making a shift with IP architecture where I'm still using a hybrid of MSTP and IP, but you can see I'm doing that, and then my air handler would be on this controller right here. I'm going to see if anyone has any questions real quick. I'm going to switch back to the computer. All right. Switch the audio, see if anything's coming into chat. Okay, nothing there. Everything's looking good there. All right, so now I'm going to switch back to the whiteboard, and we're going to go to a slightly more complex architecture. Still single building, still single subnet, but it is going to be a bus architecture now. All right. So let's clear this bad boy off. Let me figure out how to do this on this brand new kind of little architecture thing we got going on here. Let's see. Nothing. All right. Clear strokes. There we go. All right. Switch you over to white. Okay. Still got a single switch. Still got a single building. Now what we may find ourselves doing is, for whatever reason, we may find ourselves being expected to do an all IP architecture. Now what we would find is same building, we have an AHU, and let's just say we have 20 VAVs. Okay, so continuing along, staying on the same subnet, and I'm going to start adding IP addresses and things like that on the next diagram, but not on this one. We have a controller here, right? And this could be our advanced controller, which is doing our AHU. And then on this, we could start running our ring. So we would have a controller, or sorry, not ring, our bus, a controller. And each controller has 2 ports, one for the incoming Ethernet and one for the outgoing Ethernet. And so from an architecture standpoint, it's pretty simple. And with 21 devices here, we could start looking at what kind of subnet size do we need. And so with 21 devices, the general rule of subnetting is 32 minus whatever to the root of 2. Where's my eraser? as you all know, if you've ever listened to this podcast for any amount of time doing math on the fly, it always ends up disastrous. Just off the top of my head, I would probably say that for 21, we would want 2 to the power of 5, which would give us 32 devices in a addressable range. So we have 32 IP addresses. So 32 minus 29. So that's /4. Okay, good. So we're /29. All right, my math is right. So this is my CIDR. This is my size of my subnet. We'll come back to that in a little bit. But right here, we're getting 32 IP devices. And, if you take away 1 for the default gateway and 1 for the broadcast address, you're going to still have plenty to go and address across here. But very simple bus and star hybrid architecture for a single building. All right, let's clear this out. And I'm going to take a look at chat, see if we have any questions, and then I'm going to do a ring architecture, and then we're going to start getting into more complex architectures. All right, not seeing any questions so far. Looking like we're good. Let me refresh everything. And let's go here. All right. Okay, so we're back. Should be hearing me just fine. Let me just double check. Okay. So now we're going to move into the concept of a ring architecture. So once again, we have a switch. Our switch now is going to have 3 ports on it. It would add, in actuality, it has more than 3 ports, but 3 that we're utilizing. And we would say we have an AHU once again, 20 VAV boxes, and we would star off for our AHU. And then for our VAV boxes, quite simply, we would start our ring architecture. 1 port would be blocked per spanning tree protocol, and 1 port would be open. Now, we haven't talked about 802.1x, which is port level network security yet. We haven't talked about really spanning tree, and we're not going to talk a lot about spanning tree. And we haven't talked about VLANs, and we haven't talked about routes. But as we determined in this previous architecture, what was it, a /20, I put 28 in the previous, or 29 in the previous, but it should have been 28. /28, which would give us 4. Actually, no, it should be /27. My bad. Like I said, folks, math on the fly, never good. So /27, which will give us 32 addresses, 2 going to our default gateway and our broadcast address. And I'm going to shrink this down a little bit, and we're going to say, okay, this now, which I'm going to make blue, this is building number 1. Now we're going to have building number 2 over here. And I'm not known for my artistic skills, folks, but, we'll make it work. So I'm going to add, we're going to make you white. And we're going to put another switch in here. And just for simplicity's sake, we're going to mirror this architecture. So we're going to say we have an AHU and we have 20 VAVs. Problem is, these are separate subnets unless we set it up accordingly, which we're going to look at both ways. We're going to assume they're separate subnets here, and then we're going to talk about a VLAN to make them non-separate subnets. So we're going to have 3 ports once again. Star pattern going to our AHU controller, ring pattern going to our terminal unit controllers. Okay, pretty simple. Now the problem is neither of these can communicate with one another, which is why we now have to introduce the concept of some layer 3 device. In our case, it's going to be a router. Okay. And this layer 3 device is going to have a route, and this is where that default gateway concept comes into play. So what we would have to do is distribute our IP addresses, typically in coordination with IT, but we have 2/27s on each side, and let's say for this one we're going to do 192.168.1.0/27. And over here, we'll do something simple. We'll just do 192. Let me undo that real quick. Hold on. 192.168.2.0/27. And then we'll have to have some link, typically /30 right here for the link between these two routers. So what will happen now is we'll start to distribute IP addresses, right? So we'll have to give an IP address to the port on the router. This is going to be our default gateway, and we'll have to distribute addresses to each one of our devices. And the same here as well. And so what does this look like? As a BAS professional, you either need to work with the IT group or you need to start laying out on your network riser what are the IP addresses, what are the subnets, and then where do I need routes? Because remember, all of this stuff, which I realize you can't see me moving my hand, all the stuff where I'm drawing the red circle, that all is speaking on one subnet, and where I'm drawing the second red circle, it's all speaking on a separate subnet, and they can't communicate with one another. Now, we haven't also talked about BBMDs. We'll talk about that in just a second, but I'm going to step back to the screen, see if anybody has any questions so far, and then we'll hop back in here. There we go. See if anybody has any questions on anything I'm explaining so far. I mean, it's pretty straightforward, right? It's not too bad. It's a pretty straightforward subnetting concept here. Okay, cool. Not seeing anything. Let's move back over here. All right. So I'm going to assume you're using Bacnet IP. Pretty much everyone is. We're going to have a BBMD and a BDT, Bacnet Broadcast Distribution Table, Bacnet Broadcast Management Device. We're going to have one on each subnet. So we're going to have to account for that. And what we're going to do is we're going to say typically our advanced controller for our AHU usually will have a BBMD built in. Right, so it'll act as a BBMD, and we will have to populate the BDT, Bacnet distribution table, or broadcast distribution table, sorry, with the address of each BBMD, and we'll have to do that on each subnet. But up to this point, pretty simplistic architecture. Building 1, building 2, IP addresses, stuff like that. Now we're going to shrink this even more. I realize it's probably getting pretty small on your screen now, so just go with me. But what we're going to do here now is we're going to introduce maybe a larger building. And this larger building, right, maybe we have, let's do something crazy here. 500 VAV boxes and 20 AHUs. Now, I've seen a lot of folks, the temptation with this is to be like, oh, I've got 20 AHUs, 500 VAV boxes, /23, which would give you, in theory, 510 IP addresses. That's a horrible idea because now you've got this massive network space to manage, and so you've got to figure out how do I manage this effectively. What I tend to do in these situations is and we're going to blow out this building here, this blue building, and we're going to make it a little bit bigger here. what I tend to try to figure out is what is the distribution of my IT assets or my IP assets, so my controllers, and then where are the MDFs and IDFs. So IDFs typically exist on each floor, usually near the elevator, and they run all the way to an MDF, which will typically sit right at the bottom of the building and be used as the distribution point back to the core network. So our IDF closets, which are going to sit typically on each floor, which will make this a 6-floor building. So we'll have 1, 2, 3, 4, 5, 6, and a basement. And our IDF will typically have our switch inside it, right? And so I'll blow this out real quick. And inside our switch is where our ports are going to be, right? So we'll blow this out even more. And we'll give a port right there and a port right there. And maybe what we do, let's say we have 500 across 6 floors. Maybe we'll say that we have 50 boxes on the first floor, and then every other floor has, 125? So we'll make it 600 VAV boxes just to make this math make a little more sense here. So 600. And then we'll put 125 boxes on each floor. So what we're going to want to do here now, right, is we're potentially, like, if it were up to me, what I would do is I would have a VLAN per floor. I would have a subnet per floor. And so in that case, with a subnet per floor, you're going to be looking typically at like a /25, which will give you 126 devices per floor. So you'll have one spare address that you can plug your laptop in for configuration. So what that would look like at each switch here, we would most likely use a ring architecture, and we would go out to our devices and we would come back. And I'm going to make this a little bit smaller. There we go. But this would be our /26 subnet. And it's not going to look smaller, unfortunately, because of how I've got it zoomed. But this would be on each floor. And then we would have to have one of these devices having a BBMD BDT capability to go and interchange between these. Now we would have a port, and all of these switch ports on each floor would most likely go back to a router, and this router would have routes to each IP address on each floor. Any questions so far? I'm going to see if anyone has any. Okay, I see I got a question. How do I delegate the layers of the devices? When you say delegate, what does that mean to you? Let's see. If you're talking about how do I separate which subnets are which, that is typically at the mercy of the IT group. But sometimes what you'll do is you will go and work with, you'll just work with your own internal team, and then you'll turn over the network at a later time. So I'll wait for you to type your question. And while I do that, I'll build out this architecture a little bit more. Okay. So what we would do here is we may do something like 192.168.1.0 and then .2.0, .3.0, .4.0, .5.0. This one being 50. So these would be /25s. /25/25/25. And then this one being a 50 would be a /26, which would give us 64 addresses. And would be good right there. So with 64, that would actually give us 62, because remember, we always have to take one for the default gateway, one for the broadcast address. And then all of these would go back to our router, which then would have routes in it. And we would have to go here as well on each floor, which I'm going to indicate with a red line just across real quick. Each floor, we would have to go and have a BBMD on each subnet. But you can see kind of how I'm building this out. It's not a terribly difficult concept. Really, the hardest part of all of this is coordinating with the existing IT group on their subnets, because they may not want to give out certain address pools to you, which I'll talk about another way to handle that as well, which is like using an IP router or something like that. Let's see if you answered your question there. All right. So Jose asked, how do you calculate those numbers? So it's basic subnetting. If you recall, I went over it briefly in the previous episode, which was 364. And what I did was I talked about how the IPv4 address range, right? That is a 2-bit or a 32-bit address range with 2 states per bit. And basically what that means, when you see someone do /24, that means the first 24 bits of an IP address, because it's 4 sets of 8-bit arrays. So think about a MAC address on a Bacnet MSTP controller, and you have those 4 DIP switches. And when you flip them all up, that's supposed to equal 256. That's essentially what's going on with, or 255, right? Yeah, 255. It's supposed to equal 255. So you flip all of those. That's essentially what's going on with addressing. So what I'm doing here is when you see /25, and I know this is a little confusing, like in episode 364 at podcast.smartbuildingsacademy.com/364, I included a link to past networking videos and podcasts where we went into this in greater detail. But essentially what's going on is that bits 1 through 24 on a /25, and if you see me looking over, I'm looking at the whiteboard over there. Bits 1 through 25, right? Those are network bits. Those are allocated to the network. So then bits 1 through 24 would be network bits. 25 through 32 are allocated to host. So if we have 32 bits and we subtract 25 from that, that gives me 7. 2 to the power of 7 is 128. I subtract 2 from that because I need a host address, a network default. Oh my gosh. Default. Oh, why? My brain is forgetting. Default gateway. Why did I want to call it default host? Default gateway address and a broadcast address. Default gateway is where all IP traffic, internet protocol traffic that's not meant for that subnet goes. And broadcast address is when you send out a broadcast on a subnet, it goes out and then returns traffic to that address. So you see /25, that's 128. You see /26, that's 64 addresses minus 2. I know it's a little confusing, but that's like subnet math in a nutshell. Did that help at all? I may have confused you more, Jose, but hopefully that made some semblance of sense. All right, we're going to switch back to the screen. Let's go off of here onto here. Switch to that. There we go. All right. So up to this point, we're like super duper happy. Everything's working. Everything's great. We had a customer from one of the large OEMs who's going through our IT course call us the other day, and he was trying to troubleshoot because he had an IP address pool issue where the customer did not want to give them addresses. So we're like, how can we make this work? And what we decided was we got a Bacnet router. And what we did with this router was we had one incoming IP address, and then using PAT, which is port address translation, we were able to split it across 4 addresses. So they were able to create their own /26 address pools that did not interfere with the customer's address pools, because the customer was giving them their own I think it was /28 IP address range. And then at the Bacnet router, we were splitting this. And that's one way you can do this. That's the nice thing about private addressing, is that with port address translation, essentially we take this address right here and we give each one a port, and so we're able to go and divide it across that. Now that's one way you can do things, is you can do that, and it works pretty nice. It's a way to avoid having to ask for a ton of addresses from IT. An additional thing that I see a lot of people do is they provide this infrastructure right here. They provide the switch, they provide the router, and then they have a single port here which connects to the customer's IT network once the customer actually goes live with their network. So that is one way you can do it. And these would be industrial switches and industrial routers that you would put in place during the construction process. So this was a lot. I hope it gave you a baseline understanding of what the architectures look like. You would diagram this out. Ideally, what you would do is you would have a network riser diagram, but then beyond that, you would have a network list. So it'd be controller name, controller MAC address, IP address, port. So that's the physical port that it's connected to. And in the case of a ring, you would just reference the port from the previous controller. So you would say, like port 1 is from controller whatever. And by building out this list, you then know what devices are what. There are a lot more concepts in here that we didn't discuss. We didn't discuss something called DHCP and DNS. DHCP is Dynamic Host Configuration Protocol, and DNS is Domain Name Services. What we're seeing with a lot of newer controllers is that they are getting a domain name. So they're getting basically like a masked, it's called oh my gosh, term is slipping my brain. What is it? I just got back from camping, so my brain's still catching up. Oh my gosh, it's on the tip of my freaking tongue. It's it's basically a placeholder domain address. So you would say like BAS dot, penn.edu. And so it'd like be BAS penn.edu, and each controller would actually be like BAS1, BAS2, BAS3, whatever. And by giving a domain name, what that does is that decouples you from having to have a static IP address on that controller, so that if that controller changes, because it has a pool of addresses it can call from, if that controller's IP address changes, then it doesn't matter because you're pointing at the domain name, not at the IP name. This is going to become really important as a lot of people move from IPv4 to IPv6 IPv6, which IPv4 is a 32. Oh, let me flip my pen. 32-bit address. IPv6 is a 128-bit address, and it's represented in hex, not in numeric form. So it's going to be a little bit confusing, which is why you see a lot of people moving to things like domain name services. I'm going to look at the screen real quick, answer some more questions, and then wrap this up. All right. I didn't know you could use NAT on a Bacnet router. Is that common? Not terribly common, but it is something you can do. It's more so typically used to take a public IP and translate it to a bunch of private IPs, but it is something you can do. Usually, though, getting the IP address pool is not terribly difficult unless you're with a larger customer. The reality is a lot of folks are moving to IPv6, which a lot of what I just taught you kind of goes out the window at that point, because you move from 2 billion address pool to a ton of address. I mean, like, they said something to the effect of you could address like every square inch of space or something. It's some crazy number. OMB points out that it's important when using certificates. I assume you're referencing DNS. That is very important. Certificates are important, especially as we start to move to IP devices. You're seeing a lot of folks having to implement certificating. So certificating is a way of handling encryption like TLS 1.2 or 1.3. It is also a way of doing authentication. So instead of network authentication, which we're talking with 802.1x, which is port authentication, so things like MAC address sticky, stuff like that. The certificating is where you're doing application layer security, essentially. So maybe we'll do an episode on certificating in the near future. You all should be hearing me good, right? I switched mics. Good. Okay, there we go. And as well, maybe we'll do an episode on port address security as well. Port access security. I mean, the port security is super duper simple. At the end of the day, it's really MAC address sticky is your primary one, and then multiple MAC blocking is another one. So MAC address sticky is basically the first device that connects to that port. The port identifies that MAC address and attaches it to that port, and only that MAC address can access that port. It can be bypassed with MAC address spoofing, which is why a lot of people are moving to application layer security with certificates. Additionally, you have multiple MAC addresses. If you've ever plugged one of your Linksys switches with like 4 of your BAS devices on it into a IT switch or IT port, and the port goes down, most likely they had either MAC address sticky or they had multiple MAC blocking on, which basically meant that if it detected multiple MAC addresses using a single port, it would block that port as a security mechanism. So you got that. Any other questions I can answer for you? I hope you all found this helpful. It's our first time, I think, doing a podcast with the whiteboard in a long time. So hopefully you enjoyed it. And if you have any questions, do not hesitate to follow up with us. I will say, if you found this beneficial, please leave a like or subscribe or a 5-star review on iTunes, wherever you are consuming this. Thanks so much. If you like this, we'll do more content like this. And if you want a more structured, rigorous IT approach to things, check out our IT course, which will be linked at podcast.smartbuildingsacademy.com/365. Thanks everyone for being here. I will see you on Wednesday. I'm not quite sure what we're going to be covering yet, but I'll figure something out. So thanks so much, everyone, and take care.